in your book, or at least the first part of that chapter. And in doing that, we're going to take a trip back several years to the year 2005. Just last week, I had some people that were asking where I got the baseball bat that's in the back of my room, and it happens to belong to Brad Nelson, who, of course, was Mrs. Nelson's son and graduated from Garrigan and went on to play Major League Baseball. Well, back when Brad was playing in the minors, I actually made a trip at Easter time out to California to see him play. Unfortunately, he got injured right before I went out there. But in planning that trip, I looked on the internet to see what was going on in the Los Angeles area, and it turned out that the biggest news story at the time was about a guy named Anderson Hawthorne. Anderson Hawthorne was convicted of murdering a gang member. He was a gang member himself, and he was convicted of murdering one of his rivals. He freely admitted he killed the guy. There was no question about proving that. The question was what would happen as a sentence. Well, Anderson Hawthorne, who you can see in this picture, was sentenced to death. And you can kind of imagine that if you were given the death penalty, you might want to try whatever you could to get out of being executed. Well, what Anderson Hawthorne's lawyers came up with is an appeal to that sentence saying that he should not be executed because he was mentally retarded. And it turns out that the Supreme Court ruled clear back in the 1950s that it's illegal to execute mentally retarded people. This is based on the idea of cruel and unusual punishment. If somebody might not be aware of the consequences of a crime they're committing, they feel that they should not be killed for committing that crime. And this was the appeal that Anderson Hawthorne made. Well, the obvious question is, so is he retarded? That's what we want to know. And it turns out it's not as easy of a question to answer as you might think. Because Anderson Hawthorne's IQ was measured clear back when he was in school at 71. You may or may not know how IQ works, but it turns out an average IQ is 100. This is quite a ways below average. And in fact, at the time that he took that test, the state of California defined mentally retarded as 80 or less, while 71 is pretty obviously less than 80. However, a few years after he took that test, advocates for the disabled lobbied the state legislature in California to change that rule. What they said is there's way too many people being diagnosed as retarded, and that has a bad stigma to it. Sometimes people will have trouble getting jobs if they have that label. And so they wanted fewer people to be identified as retarded. And in response to these advocates for the disabled, they changed the definition of retarded in California to 70 or lower. Well, again, if I look at that number, 71, it's way below 80, but it's just above 70. So he was definitely retarded by the old definition, but he's not by the new one. Now, it's going to matter for what we're doing that IQ does have an average of 100. The idea of IQ is it's supposed to represent what percent of a normal person's intelligence you have. If you had an IQ of 100, you'd have 100% of an average person's intelligence. It turns out that the standard deviation for IQ is 15. And both of those numbers are going to matter with the other problems we do today. Average is 100 and standard deviation is 15. What the judge in this case had to decide is what percent of all people have an IQ less than 80, less than 70, or less than 71. And I'm going to cut to the chase and tell you that in reality, what the judge in this case did was sort of decide not to decide. What he said was that at the time Hawthorne took the test, the standard was 80. And he was below that standard, so they were going to enforce the fact that he could not be executed, but that he would be in prison for life. And in fact, today he is in San Quentin Prison in California. That's where that picture you saw earlier came from. We're going to look at another problem as well here. So suppose you're a college admissions counselor considering two students for admission. Jolene got a score of 25 on the ACT and Roger got a score of 1600 on the SAT. The question is obviously who did better. Now, it turns out that I actually didn't quite give you enough information to solve that problem because today there are two different versions of the SAT. One of them has two parts and one of them has three. The score I gave you would have to be based on the one that had three parts to make it comparable. Otherwise, 1600 would be literally a perfect score and it would be way better than a 25 on the ACT. But the idea here is we're trying to look at things that you can't just directly compare from the numbers. We want to know how do these things compare. And in order to answer that question, we're going to look at what are officially called standard scores, but what pretty much everybody calls z-scores. What a z-score does is it tells you how many standard deviations something is from the mean. What in the world does that mean? Well, remember I said like IQ has an average of 100 and the standard deviation's 15? Let's say Joey took an IQ test and he had an IQ of 130. You just think about that for a minute. If I start at 100, I go up 115, that would be one standard deviation above the mean. 130 is going to be two standard deviations above the mean. Well, that means Joey's z-score would be 2. He's 2 standard deviations above the mean. If, on the other hand, Eric took an IQ test and he got an IQ of 85, well, that's 15 below 100, so he would have -1 for his z-score. The way you can find any z-score is to follow this formula where it says x minus x bar over s. That means you take the raw score, like for instance your IQ score, you subtract off the mean, and then you divide by the standard deviation. So like for the example with Joey, I would have taken 130 minus 100. That gives me 30 divided by 15 is my answer. So that gives me the 2 for overall. Here's the same thing written with the Greek variables, but they're both saying that I take the raw score minus the mean, divide by the standard deviation. On the printed notes you're going to get, it has parentheses around the stuff on top of this fraction. And you might want to think of it that way too. If you're working it out on a calculator, you either need to put that numerator in parentheses or else you need to subtract, hit enter, and then divide by the standard deviation. So again, remember average is 100 and standard deviation is 15. And we're going to look at a couple of other problems along the same line. So here it says Kiana took the IQ test and she scored 155. What is her z-score? Well, what I've got to do is take 155 minus 100. That'll give me 55. I divide by 15, and I just did that on my calculator and got 3.6 repeating. You'll find that we almost always round z-scores to 2 decimal places. So what I would write down here is 3.67. Here's another one. Suppose Kelly took an IQ test and she had a score of exactly 100. What's her z-score? Now, when I asked that in my 7th hour class, they immediately told me the answer, which is 0. And that's because it's dead on average. 100 minus 100 is 0. 0 divided by anything ends up being 0. And I've got, suppose Meredith took an IQ test. She got 87. What's her z-score? So this time, what I've got to do is take 87 minus 100. and divide by 15. And if I do that, I get like 0.87, 0.86 repeating. And that ends up being below average. That's why we have a negative score. Sometimes you'll see questions that are almost like Jeopardy questions, where it's like they're written backwards. This one, it says Hallie takes an IQ test and she ends up with an with a z-score of 1.25. What's her IQ? So this time I'm giving you the z-score, and what you need to figure out is what's the actual IQ. So what you've got to do is solve an equation. And if you think about it for a second, to solve this equation, you would have to multiply by 15, and then you'd have to add 100. And I'm pretty sure if you do that, you're going to get 118.75. We would probably round that to 119. Again, multiply and then add. And here's the last of the examples of these I have. It says Riley takes an IQ test. She ends up with a z-score of negative 3.50. And we want to know what's her IQ. So same basic process. I know the z-score. I want to find the IQ. So I'm going to multiply by 15 and then add 100. And she ends up with an IQ of 47.5. And I picked Riley for the example because there's no way in the world that she would have an IQ like that. And if you did have an IQ of like 48, you would be at exceptional opportunities. And what's more, you probably wouldn't even be in like the work release program. You would be living all day at exceptional opportunities because you really couldn't function in society with that kind of an IQ. Couple of important little things to remember about IQ. First of all, about z-scores in general. A z-score of 0 is dead on average. When I teach stats as a night class at the college, I'll use this very question as a way of telling whether people were paying any attention at all in class. Because I'll have a question on a quiz that says, you have a z-score of 0. Is that above average, average, or below average? And the answer is dead on average. People will see 0 and think that's bad, but no, it's right in the middle. Positive z-scores are above average, and negative z-scores are below average. So 0 is the middle, positive's good, negative's bad. That's the basic idea of how z-scores work. There's one last thing we're going to talk about today, which is what's called the empirical rule. And what the empirical rule is just a quick little rule of thumb that you can use to get an idea of where things lie on a normal curve. Basically, it boils down to 3 important numbers. One of them is that 68% of all data in a distribution that's close to normal are within 1 standard deviation of the mean. On IQ, that would mean like 2/3 of people would have an IQ between 85 and 115. And I would bet the vast majority of people, even at Garrigan, are going to be in that range. At Garrigan, we're most likely to have people that are above 100, just because we don't have much of anyone that's like in the resource category or that type of category. But 2/3 of people, 68%, are basically in that big bulge right in the middle of the bell curve, between -1 and +1. 95% are within 2 standard deviations of the mean. For IQ, that means 97% of people would have an IQ between 70 and 130. You might remember earlier I said California defines mentally retarded as less than 70. So do most states anymore. And that's 2 standard deviations below the mean. A lot of times gifted is defined as 130 or above, which would be 2 standard deviations above the mean. Back at the beginning of the year, we talked about the word significant, which meant that something didn't happen by chance. Turns out that very often we'll call a result significant if it's out in the tail of the bell curve beyond 95%, because then it doesn't happen very often, and that's going to end up being not by chance. So 68% are between -1 and 1, 95% are between -2 and 2. And the other number is 99.7. 99.7% of your data is within 3 standard deviations of the mean. Basically, that means just about everything is between -3 and +3. That's why earlier when I did that example with Riley, who I said had a z-score of -3.5, that just doesn't happen. Because like 997 times out of 1,000, you're going to be between -3 and 3, and -3.5 is even further over. That just never happens. Again, 68% between -1 and 1, 95% between -2 and 2, 99.7 between -3 and 3. And we're going to look at basically that same thing presented a couple of other ways, but 68% are within 1 standard deviation of the mean, 95% are within 2 standard deviations of the mean, and 99.7 within 3. Here's one where it's just literally broken up as IQ. And if you think about it, if you add everything up, you're going to basically get the numbers that I talked about before. So again, I want you to know the basics of how you find z-scores. I want you to know that empirical rule, and I want you to be able to work out the formulas for math. And that's the basic introduction to z-scores.